Okay, after watching our tutorial of them adding and subtracting decimals, we should be ready to do this, right? So we are going to add or subtract, line up the numbers in the boxes provided, check the answers by rounding to the nearest whole number. Okay, first thing I would like you to do is this is going to be our, what I'm going to call our addition or subtraction bar. So would you just kind of make it a little bit longer so you can tell, please? And then we only have two numbers to work with, so we're going to use these two boxes right here, okay? We're going to use these two boxes, these two rows, excuse me, those two rows to put our numbers in. So we're going to look at the place value the furthest out. So in other words, when we read the numbers, what do we have going on in both of them? So what's the first number read? What's 44.05? Okay, what is that? 44 and 5/100. Okay, what is 27.18? 27.18. Wait. 27 and 1800ths. So they're both to the hundredths place, aren't they? So we can go back 2 decimal points. We can put our decimal points right here because they're to the hundredths. We need a tenths and we need a hundredths. So we're gonna. Does order matter in subtraction? What do you guys think? Which number gets to be on top and which one gets to be on the bottom? Does order matter? Yeah. Is taking 10 minus 5 the same as 5 minus 10? No. So we're going to have to start with the 44 and 5/100ths. So I'm going to get that put in. I have to subtract. So right now I'm going to get rid of my little arrows and I'm going to put a subtraction sign. And I'm going to subtract 1800ths, 27. That's kind of my way of making sure I line them up properly. Okay, you go ahead and subtract that. I'm pretty sure you subtracted decimals before you got to me, right? Let's try it. No calculators though. If you need a little help, just get your hand up. We have enough adults in here. We even have another one today. We have Mr. Rosenberry back there. He'll help out. There's enough hands up. Okay, you can save the check problem. We'll do our check problem together. Let's get the answer. What we call the difference. It's a subtraction problem. Okay, anybody get the same answer I did? 16 and 8700ths? Yeah, okay. So I didn't show all of my regrouping. I'm certain that you did though, right? What you would have to do. Can you take 800ths away from 500ths? No, so you have to get some more hundredths, don't you? So you're going to come over here and you're going to make this into a, well, we don't have anything. That doesn't have enough to take from either, does it? So we're going to go over here and take from this now. So what's this?
3.
That's going to become a 3. Okay. So now what's going to happen over here? What's this going to become? This is, we just came over here and took some tenths, so now we have 10 tenths. Well then, remember we got to borrow. We need some of those hundredths, so we're going to take this away. Now this is going to become a 9, isn't it? And this is going to become a 15 up here. Oof. And then over here, now I get over here, I see, wait a minute, now I got to take 7 away from 3. I can't do that. I need some more 1s. So then I say, okay, well I guess I better borrow some 1s, some 10s. I got to borrow 10 of them, so I add 10 more 1s to my 3, and now I have 13. Oh, now it's going to work. Okay, so my answer, I think, is 16 and 8700ths, and some of you agree with me, right? By the way, we're going to do a check problem kind of like the rounding and estimating way, but does anybody know how if you really wanted to make sure you didn't get to use your calculator, you wanted to make sure that you had the right answer for a subtraction problem. Anybody know what you can do? A way to check out, make sure you have the exact answer you're supposed to have. Anybody know what you can do? No? Well, here's what should happen. This answer we just got, plus the number we were subtracting, they better, when we add them together, they better take us back to the first number. Did you know that? Okay. Well, here's how we're going to check them though. We're not going to, you don't have to do this, but I want you to know that this is kind of like a way to help you make sure you have the right decimal part name and everything going on here. We're instead going to say, what could we rename 44 and 500s as? Nearest whole number. What nearest whole number? 44 and 500s. What should we rename it as? 44. Minus. What should we rename 27 and 1800s as? Cheyenne? 17?
Oh, that's
27. Okay. And then we're going to say, okay, what's 44? Take away 27. What's that? Anybody know? What is it, Cheyenne? Oh, I thought you knew it. 17. Okay. Would our answer that we have right here, would that round up to 17? So we're really pretty confident about our answer anyway, aren't we? Okay. So questions, anybody? Okay, then let's go do the next one. The next one's an addition problem, and it has how many numbers to be added? 3. Okay. So first of all, remember we're going to extend our bar here. We need to add this time. Okay, this is, how do we read 42.01? 42 and 100. How do we read 9.8? 9 and 8 tenths. Oh, we already have a difference. We got hundreds and we got tenths. Oh, okay, how do we read this one? 27 and? Not 10,000. 1,000. Oh, now we got even another one. Which one do we need to be concerned about? Which one gets to take over this problem? Yeah, the thousands does. So let's come down here and say, you know what? I need to put the thousands one first in my list. I'm going to start by doing that one first. And by the way, order does not matter in addition, does it? So we really could have made it be at the top of the list if we wanted to. Well then, we need the decimal points for the other two lined up with it, don't we? So 9 and 8 tenths. 9 and 8 tenths. 42 and 100. 42 and 100. Okay, what do you want to do, Harley?
Add zeros on
Yeah, you want to put some zeros in those so we can fill in those spots. So we're going to put a 0 at the end of this one. Put a couple of zeros at the end of this one. By the way, can we even put a 0 here if we want? Absolutely we can. We can even stick one there if we want. So every square is filled in. For every rectangle, actually, they are. Okay, go ahead, add those three numbers together. And then this time I do want you to do your own check problem and see if you think your answer seems reasonable. Reasonable answers.
2.
When you're done, you want to compare the actual answer with mine and see if we agree there. And then when we do our checking, our kind of like rounding to the nearest whole number method and adding them that way, do we get an answer that our actual answer would round to? Would you agree? 78 and 811 thousandths, right? If you have that one done, move on to number 3. So if you need help, you get a hand up. You can copy mine if you're having trouble, but I also want to seek some help if it's not working for you. After you've lined, if you're on number 3, after you put them in the boxes, you might want to check to see if you did them correctly. You might want to check my setup just to see are you putting them in the boxes correctly. And then you can go from there. I'll have to admit, this having to show if my regrouping is confusing for you, it's because I haven't done that for so long. I do everything up here, I don't write down all that. So my regrouping sometimes might look a little confusing. Okay, anybody need to talk about number 2? Let's quickly decide. Do we need to talk about anything in number 2? That's 7. You're supposed to end up with 78 and 811 thousandths. Okay, then number 3. Anybody agree with my answer? Anybody got that one done? Anybody agree with my answer? 3 people who do. How would we check ourselves out in this one? What are we going to round this one to? 100 what? 4. What are we going to round the other number to? Well, is that 21 thousandths enough to make it 87? Probably not. Let's leave it 86. Okay. Anybody happen to know what 104 take away 86 is? Okay. 18. Okay. So would 17 and 789 thousandths round up to 18? Would, wouldn't it? Okay. So we can feel pretty confident about our answer. Okay, we're actually going to skip that bottom part. Okay, are you cool with that? Can we skip the bottom part? Okay, what we're going to do now is we are going to listen to the other tutorial so that we can do the other page here. Okay, if I can find my cursor here. Okay, here we go. Okay.
What are scatter plots? This table shows how an insurance company rates drivers. Each driver is assigned a rating based on the number of car accidents. A driver with a rating of 1 has no accidents, while a driver with a rating of 10 has had many accidents. We can make a graph of this data called a scatter plot. On the horizontal axis, we show the driver rating. And on the vertical axis, we show the number of car accidents. We put a point on the graph to represent each pair. We start with the rating 1, and then with the rating 2. Notice that this point is between 0 and 2 on the vertical axis. Now we make points for 3, 4, 5, 6, 7, 8, 9, and 10. We use scatter plots to help us see patterns in the data. Can you see a pattern in this plot?
What do you think? Is there a pattern?
We see that a person with a low rating has a low number of accidents. Drivers with a high rating have a high number of accidents. We also see that the graph goes up from left to right. Let's look at another set of data. The table compares ability to play piano to the ability to play basketball for non.
And actually, we are gonna stop that, because what I want us to do is I want us to practice doing one. So that did show what we would call a relationship between the driver's rating and how many accidents they had. So we would call that a direct relationship. Okay. So we're going to check to see, is there a relationship? Is there a direct relationship in this particular situation? So everybody turn their page to the problem-solving activity. The police in Jefferson County are concerned about speeding on Highway 601. They want to see if there's a pattern in the number of speeding tickets that they give out and the time of the day. So we're going to plot the data, and we're going to answer some questions. So they already have some information on our plot here. Here's our data. So they say we're going to put the time of day on the horizontal axis. So let's do that right now, but we're not going to put 7.00. We're just going to do 7, and we're going to say AM. Okay? 8, it just goes up by hours. So everybody follow across and get this done on your scatter plot. Get it labeled, okay? So let's do that first. And then all of a sudden it switches to 12, or to PM at 12. Well, you can read yours better than this smart board is doing it for me. So the time of day is going to be represented on what we call the horizontal axis. And we need labels. Graphs need to be, they aren't useful unless we can tell what's happening on them. Vertical axis, they've already labeled the numbering part for us, but they haven't put the title on there yet. So on the vertical axis, we're going to have the speeding tickets. How many speeding tickets? So I want you to put speeding tickets as the title for our vertical axis, we call it. Okay? So speeding tickets. How many speeding tickets do they give out is going to be represented on the vertical. I'm not really sure how good we are with graphing on the coordinate plane. Are you guys good? Got that? Count down? So when we graph, we are going to, with the time of day, and then speeding tickets will follow up to how many tickets that is, and we'll put a point, won't we? What's the vertical axis going by? How many units are represented between every grid line on there? Okay, 5. So we have to take that into account. That every grid line isn't one speeding ticket. Every grid line is 5. It's 5 more. Okay, so at 7 a.m., 25 tickets. So we go at 7 a.m., we go to 25. Well, that's an easy one to do. Here we go. 8 a.m., 24. Well, 24 is between 20 and 25. Which one's it closer to? 25. So we're going to put it probably just below 25. Right? 9 a.m. 35. Okay, you will plot all those points. Get all those points put on your what we call scatter plot. Kind of, look at yours and see, just use kind of like mine. You're all done. And then start thinking about it. You think there's a pattern. See a pattern looking at all those points. What do you think? You just pattern. Are those points kind of up and down and all over the place? Yeah, so we're going to say no pattern. Let's go down here. It says, based on the data, is there a pattern? We're going to say no pattern. The points are all over the place. I mean, there's no anything we could say they're continuing to go up because all of a sudden they drop down. And then they go back up again, and then, it's kind of like there's just no pattern going on there whatsoever. And then what do you think? Do you think there's a relationship? Do you think that the highway patrolman or whoever it was, can they make a judgment call and say, you know what? It depends on the time of the day, how many speeders we have on Highway 601. Is there a relationship? There's no pattern, is there? No. So we would say, this is not a direct relationship. Let's put that in our notes here. This is not a direct relationship. Time of day, in this case, time of day has nothing to do with the number of speeding tickets given out. Okay, go ahead and get that finished up. If you're finished up with it, you can put your workbooks back. Your homework out to you. So your homework should be getting passed back to you after the front tables are back at your table. Make sure you pass them back to the other students. Don't just worry about yourself. Pass them back to the others. And you already know what routine for homework, so we shouldn't have to talk about it, right? Anybody have any questions or concerns before you leave me today? No questions, no concerns. Life is good. This is assignment number 11. Assignment number 11. Remember, they're not calling the lesson numbers anymore. Come on.